Hi guys, I'm trying something a little bit new here. So we finished chapter 3. We just have about 16 more to go. So I'm gonna try this to make it speed up a little bit better. So these are your homework for your chapter 4, reaction and solution stoichiometry. I don't know if we're gonna have time to really look at those sections today, but do read section 119 to 123. Also page 133, 134, and also 131. So make sure you get those things done. Yes. So we should be able to, I think in part 1 we should be able to get to all of the precipitation reaction. So we could get those done. Yeah. One thing I do find out about our slide or our curriculum is that they don't really go into the concepts. So if you need help on understanding some of the things, reading a book is definitely going to be one of the best way to get more the conceptual stuff. So I'll do my best to in that format. So today we should be able to get to at least the part with our types of reaction, the precipitation reaction, the acid-base reaction, and oxidation reduction reaction. We should be able to get through this, and we should be able to write our net ionic equation and also work on our particulate diagram representations. So a chemical reaction is a process where reactant transform into different substance or product, often involving the rearrangement and the formation of chemical bonds, resulting in a new substance with distinct properties. So this is a definition of chemical change. So we should have known this from our last year of the course. This is in contrast of physical change, where the chemical composition doesn't change. So physical change, you don't have a new substance, but with any chemical change, you do have a new substance in this case, right? Because a new substance is formed for any chemical change. So the bonds break, they rearrange their bonds, and they form new bonds in the chemical reactions. So it's just a way to notice it have happened. So all of the substance we'll be working with will have precipitate forming. So we're gonna have our 2 labs, one about the precipitate forming lab and one about our double replacement lab. So they kind of hit on similar point, so that we could just get those done. But what does precipitate mean is that a solid substance will come out when the 2 solution are mixed. So you can get something that happen. Other things could be a color change. So usually color change will indicate there's a new compound, because color is one of the intrinsic property of the thing. So if they reflect different wavelength, it will certainly notice those. One of the things that we're gonna notice as we are, right, so this should be after our copper chloride pentahydrate lab, is that you can see that with when the copper chloride loses the H2O, right, the color changes. So there is an indication for those things that happen. Absorption, evolution, or absorption of heat, that's gonna be a big thing. Exothermic recoil is gonna be releasing, right? Exiting, whereas into is entering into the chemicals. Okay, so this is gonna be huge. This is kind of what determine if reaction is gonna go. So we have 2 chapters just dedicated to one thermal chemistry and second about entropy and free energy. So those are the two things that really gonna dedicate if a reaction gonna happen or not. Formation gas. So bubbling and fuzzing. So remember that we have our CO2 being released when we did our first lab, indicating that it still occurs. So we have to wait for the bubbles to finish, so that we could weigh our product. Change the odor, so that it's gonna be a little bit and also though I don't think we have that much reaction that changes odor. But one of the things I can think of, if we use vinegar and then we neutralize the vinegar later when we're working with the acid and base, then you might not smell the vinegar anymore as we have neutralized it. So changing into state, such a formation of a solid. So this is kind of very similar to our precipitin. And also gonna indicate our chemical reaction if we do experience any changes of state. Okay, light emission, so combustion reaction. So when we work on our magnesium, we do have our combustion reaction. Is also going to be one of our exothermic reaction. So those called light changes state. This one's interesting because if it's just simply a change of state, that is still going to be a physical change. So if the solid and the liquid have to be in a different chemical composition in this case, in order for us to know that it's a chemical reaction. So a little bit of review about subscripts. So subscripts show how many atoms of each element. So H2 give us 2 hydrogen, where O doesn't have anything, it's just 1. It's the implied 1 oxygen. Coefficients show how many of the molecules. So if we have 3 of the H2O, then we're gonna have 6 H atoms, hydrogen atoms, and also 3 oxygen atoms. Still matter, solid, liquid, gas. Those are things. The aqueous is gonna be a new thing, so do keep those in mind. I think later on it's gonna say the AP test don't require you to have the state of the matter symbol, but for us the best practice is to put those down, especially with the aqueous. It's gonna help us indicate what ion is gonna dissolve. So we'll talk more about that in a bit. So double replacement, it's gonna be our participate reaction. So not all the time, but for all the reaction that we look at, that's the one that we're gonna do. Is one of the easiest way to spot if a reaction have happened. Acid and base reaction, so we're gonna look at acid and bases. Also they gonna look at carbonate. So the one that we did with our vinegar plus baking soda is gonna be one of what they call a pseudo acid and base reaction. We're gonna look into why. Oxidation and reduction reaction, we're gonna talk about those, why it's called oxidation and reduction. Another way that they might shorthand it is called a redox, right? Reduce, oxygen, oxygenated redox. Numinal is gonna be a good example of a redox reaction where reaction happen and you do see the light up when aluminum is bonded to certain chemicals. So this is commonly used to find out the presence of blood in crime scene. So this is what we're going to focus on, and then if you can finish this, we'll be happy. Double replacement precipitation reaction. Double replacement, 2 compounds switch to form 2 new compounds. And it used 2 different products. So most of the times when we talk about this, we're talking about ionic compound. We're not talking about molecular compound, ionic compounds. And another way that we call it salt. And salts are anything that is metal combined with non-metal. Okay, so in this case, the A and X is gonna switch places. So now instead of being A bond to B, you have A bond to Y, AY, and X instead of bond to Y, it's gonna come bond to A, so we have XB. So you're not gonna see the other way around, where you're not gonna see A bonding with X or B bonding with Y. And the reason is if A bond with X, that's gonna be a metal to metal. and B to Y is going to be a non-metal to metal or to non-metal. And in the presence of both, they tend to bond with the opposite instead of just with themselves. So later on, as we go through our chapter, our free energy and then entropy, and also our bond energy is going to help you understand why that's the case. So for example, in our, we have silver, nitrate, nitrate, bonding with sodium chloride, and you can see that silver and the sodium have switched places. Now it's silver chloride and sodium nitrate. Okay, so you're not gonna see NO3 bonding with chloride, or you're not gonna see Ag bonding with sodium in this case, and that's because they have between the metal and non-metal, they do have a greater attraction than just between metal and non-metal to non-metal. Okay, so if it's a precipitate, then you have the S symbols indicated as solid, right? So they came out of the solution and become solid, so we can observe it. Some of the things would be golden ring, lead, iodine. I've done this with my other chemistry class too. It's pretty fun. It's just like what you're gonna do with the lead iodine afterward, you know? That's kind of the thing. So how do you safely dispose of those? So one of the things you need to know is the solubility rules. So the only ones in the pink, so this is a table F from your book, but only one on the pink is really the ones that you need to focus on. So those are the three that are gonna be completely dissolved in water every time. Okay, so if we see those, we can automatically assume that they are dissolving in water. So those are gonna be our group 1 ion, lithium, sodium, potassium. So they do have their characteristic. They are, they like to lose one electron, and that tendency is so strong that it will be hard for you to get them to do combine with other other ions in the solution. Okay, another exception is gonna be ammonium, NH4 plus, and nitrate, NO3 minus. So you only have three things to remember. There's a bunch of other ions that they have, but you don't have to memorize them. So those are a lot of rules. But for our AP, we are primarily focusing on giving you compounds that only have those three rules right here. So you could, if you want, you could read those. Those are the things that you need to know, and we will not be assessed on other solubility rules. Okay, so I'm gonna